Hello everyone. Welcome to one more session of live discussion with Ashwini ji and Suresh ji. Today our topic of discussion is nanoelectronics and nanotechnology in electronics. So my first question is what is nanotechnology and how does it apply to electronics?
So nanotechnology basically a science using which we can manipulate the matter at the nanoscales. So we can rearrange their internal structure at the nanoscale, and we can enhance their using this technology. We can enhance their electrical conductivity, their internal strength, their reactivity, and also we can add the quantum effects. And at this scale, we can actually rearrange the molecules and atoms. Like what one of the good example of nanotechnology that you can see in today world is the graphene. Like it's a carbon, it's a kind of carbon isotopes where one single layer of carbon is very is very strong enough than all other metal, stronger than the diamond, and it exhibits a very good conductivity, and which as also poses a good strength. And one single layer of this graphene layer can give you the lots of strength to it. And so this is what the nanotechnology, where we can manipulate and rearrange the internal structure of atom at the atomic level, at the very nanoscales. And few examples of nanotechnology are the nanotechnology based transistor, integrated circuits, and the carbon tube, graphene that I have already told you. So these are the various example, and this technology can be used in the in the wearable electronics or sensor design, the actuators, and many photo and optoelectronic devices.
Okay. Uh, can you explain the concept of quantum dots and their role in nanoelectronics?
Yeah, quantum dots are actually nanoscale semiconductors, particulars that exhibit unique electronics and optical properties. Due to their small size, typically in the range of 2 to 10 nanometers, these properties arise from the quantum confinement, a phenomena that occurs when the dimensions of the quantum dots are so small that they restrict the motion of the electrons and holes, effectively confining them in a potential wall. This confinement gives quantum dots discrete atom-like energy level, making them properties tunable by the simple changing their sizes or the compositions. Mainly, it depends on the size-dependent properties. The energy gaps between the valence and conduction bands of the quantum dot changes with its size, affecting its absorption and the emission spectra. A smaller dot emits shorter wavelengths, like a blue light, while the larger dots emits longer wavelength redder lights. Another parameter is the high quantum efficiency. Quantum dots can effectively emit lights on other form of the energy, making them useful in the application requiring high precision. And the versatility, they can be made from the various materials such as cadmium selenide, CDSE, lead sulfide, PVS, and perovskites, etc. Another role in the nano electronics are quantum dots are crucial for their ability to control and manipulate electrons in the nanoscale, enabling the development of the highly efficient and the compact devices. it has so many applications such as the single electron transistor, SETS. Quantum dots can trap and transistor individuals electrons, allowing for the creation of extremely low power, high speed transistors. Another application is the quantum computing. Quantum dots can act as a qubit, the basic unit of the quantum information, due to their ability to maintain coherent quantum states. Another application is the LEDs. Quantum dots, LEDs, QLEDs are used in display and the lighting because of their superior color purity and the efficiency. Another application is the solar cell. Quantum dots improve the efficiency of the solar cells by enabling multiple excitation generation, where one photon can generate multiple electron-hole pairs. Another application, it is used for the sensor. Quantum dot sensitivity to change their environment make them useful for highly precise sensing application in the medicine and the environmental monitoring. That's all.
Okay, so what are carbon nanotubes and how are they used in electronic applications?
Actually, carbon nanotubes, normally known as CNTs, are the cylindrical structure made entirely of the carbon atoms arranged in a hexagonal lattice, resembling rolled up sheets of the graphones. They are incredibly thin with diameters on the nanometer scale, but can be micrometer to the millimeter long. Their unique structure gives them extraordinary mechanical, electrical, and the thermal properties. So, various types of the carbon nanotubes are available in the markets. For example, single wallet carbon nanotube, SWCNTs. It consists of a single graphene sheet rolled into a cylinder. These have well-defined electronic properties. Another carbon nanotubes is the multi-walled carbon nanotubes, NWCNTs, comprise multiple concentric graphic cylinder with the slightly different electronic behavior due to the inter-layer interaction. When we are talking about the properties of the carbon nanotubes, so it has the various properties such as the high electrical conductivity. CNTs can conduct electricity like metal or the semiconductors, depending on their structure. Another is the property is the high strength to weight ratio. They are stronger than steel, but much lighter. Thermal conductivity is another property. So CNT's efficiency dissipates heat, making them excellent thermal conductors. When we are talking about the electronic application of the carbon nanotubes, so first it is used as a transistor. CNT-based field effect transistor, normally known as CNTFTs, are promising replacements for the traditional silicon transistor due to their high speed, low power consumption, and the minimization potential. And another is the interconnectors. CNTs are used in nanoscale electronics as the interconnects, offering lower resistance and the better thermal stability compared to the traditional materials. Another is the electrodes. In the device like batteries, supercapacitors, and the fuel cells, CNTs improves energy storage and the delivery efficiency due to their high surface area and the conductivity. Sensors, CNTs sensitivity to change in their environment makes them excellent for the chemical, biological, and the gas sensing applications. Another property is the flexible electronics. Their flexibility and conductivity are the ideal for the stretchable and the wearable electronics. And another is the transparent conductive film. CNTs are used as the replacement for the indium tin oxide ITO in touch screens, displays, and the solar cell, offering both transparency and the conductivity. When we are talking about the future potential, so carbon nanotubes are central to advancing nanotechnology and the electronics with application in quantum computing, nano electromechanical system, and the advanced materials. Their versatility and the extraordinary property precision them as a key material for the next generation electronics. That's all.
Okay, so how can nanotechnology improve the performance of solar cell?
Yeah, so nanotechnology can improve the performance of solar cell in lots of various ways. Like I have already told you that with the use of this nanotechnology, we can make the materials like graphene, and we can have the coating of the graphene. So using the graphene, we can make a flexible solar cells. We can make even the transparent solar cells. So there are the many research are going happening there where they can make the flexible solar cells out of the graphene and using the very thin layers of graphene, because they are very conductive, and they don't require so much of materials for that. Only thin one single atom graphene layer is enough for such person. And then second is the light absorption. So using the nanostructures like the quantum dots and nanowires, they can trap the more light, they can absorb the more light than the other solar cells. And they can also help you in the energy conservation. Like I've already told you that using the nanotechnology, we can use the graphene and many other, we can make many other such conductivity material or wire that are super conductive. They possess very less amount of resistance, and so using those technology, we add it in the interconnects, and if we add those in the wiring, then we can or in the interconnect, or add them in the conductive layers, they can become a very high efficient, because most of the energy that we generate got lost during the transportation in the wire due to the high resistance or transportation between the or if you use the high resistance bits like copper and something similar in the photovoltaic cell between the layers for the transport, for the transferring the electricity to your to the solar cell, to your grid, then a lots of energy got wasted in forms of heat due to the resistance. But if we use the superconductive materials and very high conductive materials like the graphene, and using this nanotechnology, then we can save lots of energy, and we can make more energy efficient solar cells. And we can make this solar cell, like I already told you, that we can make this solar cell super flexible and also transparent as well. So there are lots of scientists already working on this to make a transparent window glass that is actually the solar cell. So whenever the light ray that fall in the room in the morning, then it not only gives you the sunlight, but it also used that sunlight, that window also being used as a electricity generator while being transparent. So you can see through the window, but still that window, it's looks exactly like the window, but it has a layer of that solar cell, very thin solar cell and transparent solar cell. So actually that window is not actually just acting as a window, but it is also acting as a solar cell that is generating electricity to charge your mobile, or or light up your room without needing any extra electricity from the power grid. And then it can be used in the nano structure and nanotubes, or we can also make using the nanotechnology, like you might have heard about the nanotechnology with cloths. So in the cloths, using this nanotechnology, we can make a waterproof or hydrophobic cloth that didn't get wet in the water. So we can use this kind of coating, that nano coating, nanotechnology based coating on the solar cell, so that when there is very any dust or any rainfall on the solar cell, then they don't they don't make a layer that become an obstacle between the sunlight and the solar cell, between the photovoltaic cell and and indecent sunlight. Because of that layer, they can become they can become the dust proof and waterproof. So we can use this in the coating for the solar cells, for improvement in and proofing it from the dust and the water. And there are lots of more ways where we can use these nanotechnology in the solar cells, and it's still in the research because it's a very new technology and it's still emerging out. So these are the few things that we can do with the solar cells, and we can use the nanotechnology in the solar cell and improve the overall efficiency and use, and we can make a more efficient solar cells.
Okay, so what role does nanotechnology play in development of sensors and actuators? Suresh sir, you are on mute.
Sorry. Sorry. Actually, nanotechnology plays a transformative role in the development of the sensors and actuators, enabling devices that are smaller, faster, more sensitive, and the more efficient than ever before. Actually, at the nano scale, materials exhibit unique physical, chemical, and biological properties that can be leveraged to significantly enhance the performance of these systems. Actually, when we are talking about the role of the technology in the sensors are devices that detects the major physical, chemical, or biological phenomena. Nanotechnology enhances their performances in the following. There are various ways. First, consider increased sensitivity. Nanomaterials like carbon nanotubes, graphene, and the quantum dots have extremely high surface area to volume ratios. This amplifier that the interaction with the target molecules, making sensors highly sensitive to minimize changes. Another way is the minimizations. Nano-scale fabrication techniques enable the development of the ultra-small sensor suitable for integration into compact systems, such as the wearable devices or implementable medical devices. Another way is the improved specific. Actually, functionalizing nanomaterials with the specific molecules, such as the antibodies or enzymes, allows sensors to target specific analysis, improving accuracy in the application, like medical diagnosis and the environmental monitoring. Next way is the faster response time. It reduces dimension and the high conductivity of the nano material facilitate rapid detection as signal propagate more quickly through their sensor. And another way is the energy efficiency. Actually, nano enhanced sensors consume less power, making them ideal for IoT, Internet of the Things, devices, and the portable technologies. When we are talking about the application of the nano-enabled sensors, so it has many areas. First, medical diagnosis. It is used in detecting the biomarkers for the disease at an early stages. Another is environmental monitoring. It measuring pollutions like gases or heavy metals. It is used in the food of safety, detecting pathogen or contaminants in the food products. Wearable technology, so it is also very useful application, tracking health parameters like glucose levels or the heart rates, etc. So it has playing an important role of the nanotechnology in a actuators. Actually, actuators are devices that converts energy into the motion or mechanical work, often forming part of the control system. Actually, nanotechnology enhances actuators in the various methods. For example, enhance material properties. Nanomaterials like piezoelectric nanowires, shaped memorial wires, and the electroactive polymers exhibit unique mechanical and electrical properties that improve actuator performance. Its size is compact. Nano actuators enables miniaturizing systems like nanobots for medical application or the microelectrochemical systems, normally known MEMS, used in the various industries. It has the higher efficiency. So actuators incorporating nanomaterials can operate with the less power, making them suitable for the precision application. It has the faster response, programmable behaviors. So there are various applications of the actuator. That's all.
Okay, so explain some of the common fabrication techniques for nanoscale materials used in electronics. Ashwini ji, I think you're on mute.
Sorry for that. So few of the techniques that we can use in making the nanotechnology based materials and fabrication of the fabrication based on the nanotechnology. One is the electron beam lithography, using which we can we use the focused beam of electron to define the pattern at the nanoscales, and we can define the structure at the nanoscale for a particular fabrication or prototyping. Then second is the iron beam milling, using which we can focus the iron beam raw and remove the material to shape the nanostructure. And then we can also use the atomic layer etching, using which using which it enables the precise removal of atomic layer and helps us in achieving the crucial nanoscale structures and the features that we want in our devices. And then we can also we can there are few other approaches that are less expensive to make that we can use in the fabrication, that is the chemical vapor deposition, where we deposit a thin layer of reacting gaseous substrate, and using which we can make the various kind of nanotechnology, and we can do the various kind of the nanotechnology based fabrication. And then we can also use the molecular beam that I have already told you. It's a little bit different where we deposit the atomic layer of the material under the high vacuum condition, and then using those things we can actually define the the what say the nanoparticle structures and layers, and we can define the property and feature that we want in the in that particular things. And this technology actually generally being used in nanostructure in nanostructure and the semiconductors. and there are various other processor always, but most of these one is the electron beam lithography, then iron milling, and then the atomic layer etching. These are the most common that being widely used for the various nanotechnology based fabrication system.
Okay, so what are the challenges in measuring electrical properties at nanoscale?
Yeah, so there are lots of challenges. One is the at the nanoscale, the classical at the nanoscale. One challenge is that these what's say
Really,
yeah.
actually, there are commercialization of the nanotechnology devices faces so many challenges. First, for example, it is manufacturing scalability and the cost. When producing nanoelectronic components at the scale with the required precision is complex and expensive. Techniques like nanolithography are costly and they may struggle to achieve the necessary throughout the large scale production. Another challenge is the material stability and the reliability. Actually, nanoelectronics rely on the advanced material like graphics, carbon nanotubes, or molecular semiconductors, ensuring that the long-term stability under operational conditions such as high temperature or prolonged electrical stress is a challenge. When we are talking about the challenge, another challenge is the integration the existing technology seamlessly incorporating nanoelectronics device into current silicon-based platform and circuit architectures requires significant adoption in the design and the fabrication process. Another challenge is the controlling quantum effect. To control its quantum effect is also very challenging as device dimension shrinks, quantum effects like tunneling and the quantum confinement becomes prominent, leading to leakage current and the unpredictable behavior that must be carefully handled. Another challenge is the environmental and the health concern. The use of nanomaterials raise questions about the environmental impact and toxicity, particularly during the fabrication and the disposal. Addressing their concern is critical for the widespread adoption. Next challenge is the testing and the quality assurance. Traditional testing methods are the insufficient for the nanoscale devices. Developing non-invasive and precise techniques to test the and validate functionality to is the very essential. Another challenge we can say about the economic viability, high research and development cost, and the uncertainties about the long-term market demand can deter investment, slowing down the transition from the lab scale prototype to commercially viable products. So in brief, we can say that the efforts to overcome these challenges include advancing manufacturing techniques, developing new materials with the better properties, and creating hybrid systems that combine the benefits of the nanoelectronics with the existing semiconductor technologies. That's all.
Okay, so what are the major challenges? So how does nanotechnology address issues of sustainability in electronics manufacturing?
Just repeat the question again, please.
How does nanotechnology address issues of sustainability in electronics manufacturing?
So, nanotechnology addresses the electronic manufacturing and enhancing the resource efficiency by reducing the waste and minimizing the environmental impact. And they can also enable the cleaner production and the process. Like I have already told you that using this nanotechnology, we can make a superconductive material, and we can also make a supercapacitors. They are better substitute the battery, so it's again helping in substituting the one of the components that might become the e-waste, and that might used that might use more energy, and that is not more energy efficient. So this is the one thing. And then the second thing is it's also enables you in contributing the in making the more durable atoms. So it's, if you make the atoms more durable, if you make some devices that is more durable, then its lifespan it means it's like it have more lifespan than the another. So the time for the recycling time, it get you get more recycling time, and you might not need much effort in the recycling frequently on that material. And so these are the things. And then second is the energy efficiency. So these nano structure where ICs and supercapacitors or graphene based devices are super efficient. They consumes very less amount of they waste very less amount of energy, because they are super conductive and due to this property. And they are very efficient in many ways. So they are very efficient as well. And then it also helps you in the waste reduction. Like if you make the material with the graphenes or somewhere with this kind of material that is the nanotechnology, or if you use the layer of nanoparticles layer on any kind of material, it's become more durable than others. Then it increase the durability, and as the durability increase, it's helped in the waste reductions. And then the second then another aspect is the smarter recycling. You can smartly recycle and recover the rare earth metal using these if we use these kind of nanotechnology things. And then I have already told you that now these technology being used in making the smart glasses, smart windows that is transparent but still can be used as a solar panel. So there is another area where we can harness the more energy from the sun, and in much a smarter way. So these are the area where this nanotechnology can address the issue of sustainability in electronics manufacturing system.
Uh, okay, so what are the latest advancements in molecular electronics?
Actually, a recent advancement in the molecular electronics showcases significant progress in using molecular scale components for the advanced computing, sensing, and the energy application. For example, DNA-based computing. Researchers have made stride in DNA computing using DNA molecules to execute Boolean logic application operations. Innovations include functional DNA sequences and their dimensions nanostructures for the biomedical applications, such as multi-biomarker analysis, cellular imaging, and the clinical diagnosis. These advancements offer high sensitivity and the efficiency, though challenges remains in the scalability and the integration. Another is the single molecule devices. Improved fabrications techniques now allow the creation of the single molecule electronics devices with the better control over the electronics properties. For example, molecules are being engineered to feature as a diode, transistors, or even memory storage units. enhancing miniaturization and the energy efficiency in the electronics. Another parameter is the biosensors and diagnosis. Molecular electronics plays a key role in developing biosensors and lab-on-chip devices. These systems leverage molecular interaction for real-time diagnosis, point of care testing, and the environmental monitoring. Another parameter is the hybrid molecular nanosystem. Advances in the integrating molecular electronics with the nanomaterials such as the graphene and the carbon nanotubes enable higher performance and the new functionalities including quantum dot application and the enhancing electrical conductivity. So these innovations are exempted to drive transformative application in healthcare, computing, and sustainable technology while addressing challenges in the material stability and the large-scale productions.
Sorry. Discuss the ethical implication of nanotechnology in electronics.
Yeah, so there are lots of ethical implication can be needed in the nanotechnology, and they can, because they can be harmful in many ways, and they can pollute the environment, and they have the bad environmental impact, or they can also be used in other in bad ways, and they can also help. They can also raise the health concerns. So let me talk about point by point. So one of the concern about the ethical implication of the nanotechnology is that is the health and safety concern. That is the toxic, because some of the nanomaterials like that we have already talked about, the nanotubes, the carbon nanotubes. So these carbon nanotubes and some of the nanomaterials are toxic, and as they are nanoparticles, they are very small. So these can be indigested or absorbed by our skin with the pores of the skin, and they can enter in our body, and that cause various health problem that we might not know, because it's very new technology. We don't know what is going to happen. We don't know its long term impact. Might not be impacting today, but we can see those impact in the next generation. They might be impacted due to this kind of technology that we are using today. So we don't know. This is a very new technology, and we haven't monitored the impact till for the long time. So it might be not impacting us today, it might be impact in the future. So these are long term effect that can be caused. So we have to monitor these things as well. And one is that and so we have to very careful while in manufacturing and using the nanotechnology based materials, and we have to especially the nanocarbon tool. And the second is the environmental impact. So nanoparticle can be cause the environmental pollution such as soil pollution and the nanoparticle pollution, and they need to be disposed in a proper way. And they can these nanoparticles, these nano layers that we are using in the current scenario, if they can be misused by some people, they can also contaminate the water, air, and the whole ecosystem. So one of the major concern is these nanoparticle can form a layer on the water, on the water layer, and contaminate the water. That can also not only impact you, but also impact the innocent animals, the aquatic beings inside the water. That is very helpful for us in making the ecological balance. So these kind of the practices that we have to take care of the environmental impact. We need to dispose these nanoparticle properly if we made any equipment using using this nanotechnology. Second challenge is recycling. These unlike the other recycling thing, like we do recycle the plastic and other waste, the equipment and devices that you made with the nanotechnology need to be recycled in proper way, and they need a proper infrastructure to do that, because we are dealing with the nanoparticles, very small particle layers, and we have to recycle in proper way. We need a proper infrastructure to do that. And second is the ethical practice for the for the workers, for the people who are working on the nanotechnology, to the factory who are manufacturing this nanotechnology. They need to provide a proper safety equipments and proper safety guards to the workers who are making this technology, who are working in this area. Because like I have already told you, the some of the nanotechnology based devices like carbon nanotubes and something like that, they are very toxic and they can absorb by the screen. So they have to practice the ethical way. Those workers have to provide provided with the proper safety gear and proper safety instructions, so that these cannot be exposed to their skin, and they don't they do not fall in some kind of health related problems. So these are the ethical practices where we need to provide the proper safety instructions for the people, proper recycling infrastructure for the whole ecosystem where that uses nanotechnology. And we provide the proper instructions to the peoples who are using nanotechnology based devices, that need to be disposed. And if we are using the carbon nanotubes somewhere, then we have to make a proper we have to provide a proper safety measures, and proper precautions for the workers, so that these do not harms their health and environment as well.
Okay, so how might nanoelectronics change the future of computing, particularly in quantum computing?
Actually, nanoelectronics is poised to transform the future of the computing, especially quantum computing, through the breakthrough in the scalability, efficiency, and the functionality. For example, enhanced qubit design. Nanotechnology in electronics enables to creation of the more stable and the controllable qubits, the building blocks of the quantum computing. For instance, nanomaterials like graphene and the silicon quantum dots allow for qubit with the higher coherence times and the improved fault tolerance. Another is the miniaturizing and the integration. Nanotechnology actually supports the development of the compact quantum process by integrating multiple qubits and the electronic components into the smaller, efficient systems. This reduces energy consumptions and enable portable quantum computing devices. So, and next one is the nanophonics in quantum network. Actually, nanoelectronics aids in building quantum network by leveraging nanophonics devices for high-speed quantum communications. This system facilitates the transfer of the quantum transfer information over a long distance with the minimum losses. Another is the room temperature quantum computing. Actually, it advances in nanostructures and the materials have pushed the boundaries of the quantum operations under ambient condition. Innovations like diamond-based qubits and the nanoscale topological insulators could eliminate the need for the complex cryo setup. And the next one is the quantum error corrections. It is also very important parameter. So nanoelectronics plays a role in improving the quantum error corrections methods. High precision nanoscale sensors and the circuits contribute to detecting and the correcting errors in the quantum systems, enhancing overall performance. So there are various factors that addressing the current quantum computing limitations, nanoelectronics not only they accelerates the development of the quantum technologies, but also integrates them into the broader computing system, fostering a new era of the innovation and the applications. That's all.
Okay, so can you describe a recent breakthrough in nanoelectronic material and its potential application?
आवाज नहीं आ रही है
Yeah,
आपकी।
yeah. One of the recent breakthrough of this nanotechnology that I have already told you that this is graphene, the graphene, and another that is already told by the Suresh that the quantum computing and the quantum chips. So let me talk about the graphene because it's one of the amazing material that is very one atom thick, and that can possess the that have the capability and the strength that more than the diamond. It's only one atom thick, and that possesses a lot very good amount of conductivity and a superconductor. You can call it it is around the superconductivity, not the superconductor, it's around the superconductivity, and that can be used in making the supercapacitor or something like that. And then it also poses the good durability, flexibility as well, the transparency as well. So this is the one of the amazing breakthrough of the nanotechnology, that is the graphene. And now we are making the various conductive inks, conductive materials using these graphenes. And like one I have here with me, that you can see that this is the conductive pen. This is the conductive pen. So this is made of the graphene. They have the graphene particles inside the ink. They combine the graphene particles inside the ink, and that makes the ink conductive. So if I want to make any kind of circuit, if I want to draw any kind of circuit, if I want to do any kind of prototype, I can simply write with this pen, and that can make a conductive layer, that can make a conductive closed circuit using this. So this is one of the good technology and good use of the graphene, that is being combined with the pen inks, with graphene is being combined with the pen inks, and that makes a conductive ink, and using which you can draw the circuits out of thing for the prototyping without being using any kind of printed circuit boards, or something like this. And this technology being now being used in making the photovoltaic cells, transparent photovoltaic cells. And then now we are making the flexible OLEDs display, sorry, flexible displays, flexible, flexible coating layers, that can make a glass, glass more tough, because there is a layer between the graphene, and that is the more that possesses the more hardness than the diamond. It make the glass more stronger and also flexible as well. So these are the graphene is the great one of the greatest breakthrough in the in for the in the nanotechnology, that can have lots of opportunity for us, lots of areas where we can use this, and lots of ways we can use this and create amazing devices. One like that, this graphene based pen that can make you the circuit just by the writing.
Okay, so how would you tackle the problem of heat dissipation in nanoelectronic devices?
Yeah, so heat deficit, generally, if you use the devices like if you use the use the materials, it's depend on the material. So generally, if you use the material like the graphene or carbon nanotubes, they generally carry they generally possess the very high thermal conductivity. So they generally didn't get much heat, and they can handle a lots of thermal stress as well, unlike the semiconductor. These graphene material can possess a lots of conductivity, and can handle lots of heat as well. And then for the for the thermal insulation, we can use the boron nitrate nanotubes, that can help you and minimize the heat transfer to the sensitive components. So these can be used in those materials to isolate the heat, if you want to protect some materials from the heat. And second is the 3D architecture of, we can stack the different ICs, or we can stack the design in the 3D structure that that helps you in either isolating the components from the heat, or either dissipating the heat to the environment, and giving the pathway to the heat towards the environment. So these are the things that you can consider and use. And we can also use the different kind of heat sinks for the heat dissipation. And we can also we can also use these nanostructure with material, or we can make an advanced material using this nanotechnology that have better heat conductivity, and that can easily helps in transferring the heat from one material to the environment, like what we call the heat, what we do in the heat sinks. So these are things using which we can help in the in the heat dissipation problem, and in the electronic devices. And we can also use these things for also the isolating the different kind of devices from the heat, from the outside heat.
Okay, so my last question, sir. If you're given a project to design a nanoscale transistor, what material would you consider and why?
So the material that I consider is obviously the graphene because I've already told you it's a super amazing material. It's a mark my word, it is going to be a very one of the most useful material in the future, and it is being used in most of your devices, in satellites, in the defense, in the space technology, in the electronics, in the microelectronics, in everywhere, because it's the material that is being needed. It's a super durable. So you can, if you make the materials, if you make the transistor using these materials, then are super durable, that can be sustained with the cosmic waves, and that can sustain in the space environment. So it's very one of the good one of the good choice of material for the space technology. If we want to use in the defense, then due to the high flexibility as well as durability and the strength and the superconductivity and good strength towards the heat and the outer stress, it is one of the best material that you can use in the defense equipment, because they can possess the good strength, robustness, flexibility, and the conductivity for the defense purpose as well. If you want to design the consumer electronics, then again it gives you the very good amount. Now the few companies are making the graphene based phones. So they are super durable, they are super efficient, because they are made of the graphene. And as the whole body of the phone is made of the graphene, they if you drop it from the height, from the very high height, then it didn't poses any kind of impact, any kind of, because of the drop force. There is they can sustain those force. And because of this super conductivity, they are very efficient, because they didn't get hit too much. And if they're exposed to the very high heat environment, they can sustain in that environment, unlike the semiconductor. If you use the semiconductor device in the high heat environment, like in desert, or where the temperature goes very high and low, then you face the heat throttling. But if you use the graphene in this kind of material, then these kind of devices, then it helps you in overcoming the heat throttling. So if you use this graphene in making the transistor, then you can not only make the transistor very small, because it's only a very thin amount of a very small amount of graphene you need to make a transistor. Using that, you can not only shrink the size of the transistor, you can not only shrink the whole size of the whole device, but it can also possess you the good efficiency in all ways, from the durability to the conductivity to the everything. So it is one of the good material, and graphene is my first choice to make using that.
Okay, so I'm done with my questions. I hope the session was very insightful for our viewers. And thank you, Ashwini ji and Suresh ji, for telling us so many things. And if you have any questions related to this topic, you can post it in the comment section. We will get back to you in the next session. Thank you so much.
Thank you. Thank you, everyone.